Black holes are among the universe's greatest mysteries, invisible, unstoppable, and almost unimaginably powerful. For decades, these cosmic beasts have fascinated scientists and sparked fear in storytellers. The first black hole ever detected was Cygnus X1, discovered back in 1964 by a group of scientists through X-ray astronomy. Since that groundbreaking moment, we've discovered countless others, some so enormous they stretch the limits of logic. We're talking about black holes with masses billions of times greater than our sun, silently sitting at the centers of galaxies, including our own dot in this video. We're going deep into the unimaginable scale of these cosmic giants, from stellar mass black holes to colossi like Ton 618, which defy comprehension. This is the true size of the universe's most terrifying forces. Welcome to the realm of supermassive black holes. But before we explore their massive scale, let's pause and truly understand what a black hole is. At its core, it isn't an object in the traditional sense, but rather a region of space where gravity is so intense that nothing can escape. Not light, not planets, not even time itself. Black holes are born when giant stars collapse under their own gravitational force. All of their matter is crushed into an infinitely dense point known as a singularity, wrapped by a boundary called the event horizon. Anything that crosses this boundary is lost forever. What makes black holes truly frightening isn't just their gravity. They don't just pull, they warp. They stretch and bend the very fabric of space and time. Near one, time slows, clocks tick more slowly, and reality becomes distorted. Fall in too close, and time could stretch infinitely, as if the universe itself freezes around you. This isn't fiction. It's the science of Einstein's general relativity in motion. And the more massive the black hole, the more extreme this warping becomes. To put that into perspective, even the smallest black hole ever found is still more massive than our sun. Meet the unicorn, the lightest black hole discovered so far. Found in 2019, located around 1,500 light-years from Earth. It has about 3 times the mass of the sun, yet all of that is squeezed into a space just 20 kilometers wide. That's smaller than New York City, yet it holds 3 suns worth of mass. Our sun is more than 1.3 million kilometers wide, but this black hole's extreme gravity compresses matter in a way that's hard to comprehend. And remember, this is the smallest black hole we know of. Nearly every galaxy we've studied, including the Milky Way, contains a black hole at its center. Ours is named Sagittarius A*, a supermassive black hole with a mass of over 4 million suns, silently lurking in the heart of our galaxy. But this brings us to a major misconception. Many people believe that black holes act as galactic anchors, holding everything together, keeping stars in orbit. But that's not quite right. Black holes don't stabilize galaxies. They're not the glue that keeps everything spinning. If Sagittarius A* were to disappear, the Milky Way would remain largely unchanged, because it only accounts for a tiny portion of our galaxy's total mass. The real structure comes from the combined gravity of stars, gas clouds, and a mysterious component called dark matter, the invisible backbone of the cosmos. Black holes might steal the spotlight, but when it comes to holding galaxies together, they're only one part of a much larger equation. Now, black holes aren't all the same. They fall into several types, categorized by their mass and size. The most common are stellar mass black holes, created when massive stars run out of fuel and collapse. These range from about 3 to 20 times the mass of our sun, spanning just a few kilometers in width. Despite being small in size, their density is extreme. Next up are the intermediate mass black holes, much rarer and still deeply mysterious. These typically weigh between hundreds to thousands of solar masses. Scientists think they may form by merging stellar black holes or within dense star clusters, but no one knows for sure. And at the top of the scale lie the supermassive black holes, the true monsters of the cosmos. Found at the cores of galaxies, including our own, they can weigh millions to billions of times more than the Sun. One of the most extreme examples is Ton 618, weighing more than 66 billion solar masses. While we still don't know how these giants form, their presence is undeniable. Now let's truly explore their scale, starting with the smallest kind. Let's go back to stellar black holes. These can still be gigantic. Take LB1, found 13,800 light-years from Earth. At first, it was thought to be 70 times the mass of the Sun, though newer estimates suggest it's closer to 23. Still, 23 suns crushed into a ball smaller than New York City. Now move up to the intermediate class. One notable candidate is GCIR S13E, sitting just 26,000 light-years from Earth near the galactic center, estimated at about 1,300 solar masses. That's like collapsing every visible star in the night sky into a single point. The largest confirmed intermediate black hole is HLX1, found about 290 million light-years away in the galaxy ESO 243. This one weighs in at 20,000 suns to 5,000 times heavier than the unicorn, yet it still isn't in the biggest class. Now we reach the supermassive black holes. Even the smallest confirmed one, located in the dwarf galaxy RGG 118, weighs about 50,000 solar masses. Still small by supermassive standards, yet powerful enough to shape its entire galaxy. In our own galaxy, Sagittarius A, around 26,000 light-years away, has a mass of roughly 4.3 million suns. Its event horizon is 44 million kilometers wide, about 30 times the size of the Sun. If you replaced the Sun with Sagittarius A*, even Mercury's orbit would fall inside the black hole. But Sagittarius A* is still small compared to what's out there. Let's travel 53 million light-years to the galaxy Messier 87, where the first image of a black hole was taken in 2019. This one is a true heavyweight, with a mass of 6.5 billion suns. That's more than 1,500 times Sagittarius A's mass. Its event horizon would stretch well past Pluto's orbit. If it sat where our Sun is now, the entire solar system would vanish into its depths. But even that's not the limit. Now we arrive at the final boss, Ton 618, located 10.4 billion light-years from Earth. Ton 618 is among the most massive black holes ever discovered. It holds over 66 billion solar masses, with an event horizon of 390 billion kilometers, big enough to swallow our entire solar system, the Kuiper Belt, the Oort cloud, and still stretch beyond. Discovered through the blazing light of a hyperluminous quasar, Ton 618 continues to challenge what we thought was physically possible. From tiny stellar remnants to unimaginable galactic titans, black holes show us just how extreme and mysterious our universe can be. In the grand expanse of space, black holes are the kings of gravity, and even now, we're only beginning to grasp their true power. That's it for this video. Until next time, stay curious and keep watching Factopedia Junction.